day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsidiso Kongwani, and this lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center. Today we will be looking at trigonometry, but not all of it, the first part of trigonometry. All right, and then at the end of this lesson, you are expected to be able to simplify trigonometric expressions, equations by making use of a calculator. Secondly, to simplify trigonometric expressions and equations by referring to special angles without using a calculator. Remember, the first one will be by using a calculator, the second one without using a calculator. And then the third one, apply trigonometric ratios in solving right-angled triangle in all four quadrants. And then now fourthly, apply reduction formula. Remember, grade 12, that reduction in technical mathematics, we only do 180 plus minus theta and the 360 plus minus theta. We don't do 90 plus minus, we do not do 270 plus minus. We only rely on two reductions, which is 180 plus minus and the 360 plus minus. That means we are referring on the x-axis line of your Cartesian only for reduction. And then you must be able to solve trigonometry equations for theta, where theta lies between 0 and 360 only. That means in all your quadrants, only up to 360. So you'll be determining the value of theta only from 0 up to positive 360. And then lastly, you will be able to apply and prove trigonometric identities. So basically we will be looking only up to the identities for today, and then the 2D and the trig functions will be our lessons for next week. And then the knowledge that you need, grade 12, before you can do your trigonometric, that means you need to collect your toolbox, and then into your toolbox there must be a Pythagoras theorem, because we will be using this throughout all triangles where you are having a triangle of 90 degrees. As you can see there, you have an angle of 90 degrees. This Pythagoras theorem, it only works with a 90 degrees triangle. And then the side that is opposite the 90 degrees is the hypotenuse side, and then the side A here is this one is opposite, this is adjacent, and then that is the hypotenuse, adjacent and opposite side. Okay, so we are relying on that, grade 12. So now this is our hypotenuse side, this is the opposite and the adjacent side. So grade 12, you are not referring to that 90 again. Let's say you have a theta angle there, okay, or an alpha angle there. Okay, now hypotenuse side will always be opposite the 90 degrees. But now when we are referring to the theta angle there, and then this angle A will be the opposite angle into theta there, and then it will be adjacent B there to the theta angle if we are referring to that one. But it will change if we are referring to an alpha now, and then we'll elaborate more when we continue about the opposite and the adjacent side of your triangle. For now, I want us to look at the Pythagoras only. So now if we want to look at the hypotenuse side, of which is our C side, we will be saying original, the hypotenuse side is equal to the sum of the other two sides. The sum, when you add the square of the two sides, you will be having the square of your hypotenuse side. Let's say now we are looking for the C side, of which is your hypotenuse. You will be looking at the square root of this part that we have added there. Why? Because this side loses an exponent. As you can see that our exponent is no more there. So if this side loses an exponent, this will gain plus minus the square root. But now in this case, because we are taking the distance or the length, So we take that as being the positive identity. So our answer will just be a positive. We are not referring to plus minus. Now, if you are looking at the A side now, if you are looking at the A side, what will happen from your C squared equal to A squared plus B squared? When we want the value of A, we'll leave A to that side and transpose B squared to that one. It will be C squared minus B squared. So now the A loses an exponent. This will gain a square root of C squared minus B squared. Hence, we have A equal to the C squared minus B squared there. The same applies with the last one. If we are looking for B from our original C squared equal to A squared plus B squared, we are going to leave B squared because we are looking for that B, and then now we transpose A to the left hand side. It will be C squared minus A squared equal to B squared. This will lose an exponent too, and this will gain a square root. So therefore it's C squared minus A squared. Hence we have a B equal to the square root of C squared minus A squared. And then this is derived from the original, where we are having the square of the hypotenuse side is equal to the sum of the two other sides. Okay, and then another thing that you need, grade 12, is your trig ratios and its reciprocals. Remember, the original trig ratios we are having 3, which is sine, cos, and tangent. And then out of this original, we are having its reciprocal. Then we'll have 3 of them. So it will be 3 and 3, which is giving us all 6 of them. 3 ratios, original, and 3 reciprocals. So from the original, remember, for abbreviation, in order for you to easily remember this, for the original, we are using SOHCAHTOA. This is SOHCAHTOA. It must be OA, grade 12. Please rectify that. That is SOHCAHTOA. And then now, if you are looking at SOHCAHTOA, what does it mean? S stands for sine. So we mean sine theta. It will be equal to the opposite over the hypotenuse. As you can see, that sine is equal to opposite over hypotenuse. And then now, if we are referring to our triangle there, remember I indicated lastly that your hypotenuse will always be opposite the 90 degrees angle. And then in reference to theta here, which is the A, angle A, the opposite side is the angle opposite the angle, and the adjacent will be that particular side. And then now when you talk to sine, when you say sine theta is equal to opposite over hypotenuse, that means when we are standing there and we are looking at the sine of theta, that will be the opposite side BC over the hypotenuse side AB. Hence we have BC over AB for that. So you must be able to do this, grade 12, and this is only applicable if you are working with a triangle of 90 degrees. The same applies as in Pythagoras theorem, only if you have a 90 degrees triangle, right? And then let's look at CA. CA is for cos is adjacent over hypotenuse, and then the cos of theta now will be adjacent over the hypotenuse. We are referring to theta. What is adjacent side? Is AC over the hypotenuse side, which is AB. That is how we come up with that fraction AC over AB. And then with the tangent now, tangent is opposite over adjacent. So the tangent of theta will be the opposite side, which is BC, over the adjacent, which is AC. So grade 12, that is how you come about those ratios that we have there. And then now let's look at the reciprocals now. What do we do with the reciprocals? Remember, the reciprocal of a sine is a cosec, of a tangent it's a cot, of a cos it's a sec. So now if we say CHO, they say CHO sometimes. To remember that, you must know that now we are looking at the cosec. If this was opposite over hypotenuse, this one will be hypotenuse over opposite. That means we are swapping around, grade 12, because this is the reciprocal to each other, as we have indicated this in the same column there to show you. So now cosec of theta will be hypotenuse over opposite. If this was BC over AB, the reciprocal will be AB over BC because we are swapping them around. So that is how they relate to each other. And then now let's look at the reciprocal of a cos. A cos is a sec, so we say sha is a sec is equal to hypotenuse over adjacent. That means the sec of theta now will be hypotenuse over adjacent. If cos was AC over AB, the reciprocal will be the inverse of that, which is AB over the AC. Lastly, we are having TOA. This is supposed to be a because it's a cot, okay? That is not T, that's supposed to be C. And then now, if we are now looking at the reciprocal of a tangent, that will be a cotangent, cot. And then if the tangent was BC over AC, this will be AC over BC because we are swapping around. If this was opposite over adjacent, it will be adjacent over opposite for the reciprocal of that particular ratio. So that is how we work around the reciprocals and the original ratios, grade 12. Sometimes you can put this, you can also put this in your quadrant sketch where you are having cast diagram. So we know that if you are having a sine, you can also put a cosec there to remind you. If it's a tangent, you can also put a cot. For the cos, you can put a sec there, so that you can know that sine always goes with the cosec, a tangent goes with the cot, and the cos goes with the sec. So it will be in one unit circle that you will be referring to. Right, this is the circle I'm talking to. You can design any diagram that is suitable for you. And then now this is for reduction formula. We are using this mostly in reduction. And then remember now with technical maths, reduction, we are only referring to two. That is the 180 minus 180 plus and the 360 plus or 360 minus. We are only using 180 and 360. This 90 and 270, we will never touch that in technical mathematics for reduction. We only rely on 180 and 360. So now we are only using these two here. Okay, and then now if we are in quadrant 2, remember this is a cast diagram to remind you. It's a cast, C-A-S-T, cast diagram. So if I am before 180, that means I'm less than 180. So it's 180 minus. That is why we are having this 180 minus theta there. If I have passed 180, then I am more than 180. It will be 180 plus. That is why we are having a reduction of 180 plus there. Then if I'm in quadrant 4, if I'm before 360, that means I'm below 360, which is 360 minus. Then that will be a 360 minus. Then if we are revolving for the second time, it will be 360 plus. You revolve and finish and revolve for the second time. That is why we are having a 360 plus there. So that is the reduction. And then when we count our quadrant, we do it anti-clockwise. Remember the clock, we move this way, but for this one is anti-clockwise. It's quadrant 1, quadrant 2, 3, and 4 anti-clockwise in that direction. Okay, that is anti-clockwise. Right, and then you need this diagram for reduction where you are checking your ratios, whether is it positive or negative. And then you also need your special angles. When you talk special angles, we are referring mostly to 30, 45, and 60. And then we have also included the 0, the 90, 180, and 270, because those are the angles on your Cartesian grade 12s. That is a 0 degrees, a 90 degrees, a 180 degrees, at 270 degrees and the 360 degrees. Those are the angles on a Cartesian plane. Then we have included those two. And then now your angles here, 0, 30, 45, 60, 90, 180, those are in degrees. And then we have given a notation of those angles in terms of radians now. 0 will remain as 0, but 30 degrees is the same as radian over 6, and then 45 degrees is 1 over 4 radian, 60 degrees 1/3 radian, 90 degrees 1 over 2 radian, 180 is 1 radian. That means when I'm at 180, I know that I will be referring to a radian. And then when I am at 360, because 360 remember is 180 times 2. That means the same apply. If 180 is radian, that means 360 will be 2 radians there. So that is how you can be able to remember this. And then now, when you are at 90, we are at radian over 2. And then when you are at 270, you are at 3 over 2 radian there. So that is how we relate the degrees to the radians there. And then now, grade 12, if you are having the sign of 0, it will be 0. And then the sign of 30, it's a half. Sign of 45, it's 1 and over square root 2. Sign of 60 is square root 3 over 2. Sign of 90 is 1. And then sign of 180 is 0. Sign of 270 is minus 1. The same applies with cos of 1. Cos of 0 is 1. You can check with your calculator. Cos of 30 is square root 3 over 2. Of 45 is 1 over square root 2. And then the cos of 60 is 1 over 2. The cos of 90 is 0. Cos of 180 is minus 1. Cos of 270 is 0. So this table is talking to those values. Or you can use your triangles, or you can use your calculator. But please do not simplify your answers and remove the radians. It must be in radians, because you will be working mostly, your questions will be saying without using a calculator, where you are applying special angles. Right, and then we have trigonometric identities. We are having 3 classes under this one. We have square identities, reciprocal identities, and the quotient identities. Remember, a quotient is an answer that you get when you divide. Okay, and then square identity, it works only if it has squares. Without squares, you cannot apply these identities. They work only if they have squares. So that means the sine square theta plus cos square theta is equals to 1. Or you can leave the sine square theta, maybe if you play around with this and transpose this to the right hand side, you'll end up with 1 minus a cos square theta there. Or you can leave a cos square theta and take the sine to the right hand side, it will be 1 minus a sine square theta. That simply means, grade 12, where you are having 1 minus sine square theta, you can remove and write cos square theta, depending on the problem that you are solving, the need of the problem. And then the same applies now. The second identity, we are having tan squared theta plus 1 is equal to a sec squared theta. The same applies here. You can leave a tan square theta there on the left hand side and take 1 to the right hand side. It will be sec squared theta minus 1. So for this identity, you can also write it in this format. Lastly, identity square is 1 plus cos squared equal to the cosec squared theta. So that means for this one also, you can play around with this, leave a cos squared theta, and then you'll end up with the cosec square theta minus 1 for that one. And then the reciprocal identities, remember reciprocals, we are now talking to cot goes with tangent, and then sine going together with cosec, and then the cos going together with the sec now. So if I'm having a cot, I can write as 1 over tangent. The same applies if I'm having a tangent, I can write as 1 over cot. Okay, and then the same applies, cosec can be 1 over sine, or if I'm having a sine, can be 1 over cosec. And then the sec of theta is equals to 1 over cos. Also cos can be 1 over sec. You can play around also with those reciprocal identities. And then with the quotient identity, it's quotient because it's having a division line. So tangent is sine over cos, and its reciprocal cot will be cos over sine. That means this quotient identity works only with tangent and a cot. Okay. And then now you need degrees and radians. I touched this a little bit previously now. And then in this case, grade 12, you must know how to convert a degree to radian and a radian to degree. That means if you are changing a degree to radian, you must multiply that degree with a radian over 180. For an example now, let's say we are having a 90 degrees here. Multiplying by a radian over 180. Remember, 90 here goes once into 180, it will be twice. That is why your answer will be radian over 2. Hence, we have that notation there, that 90 degrees is the same as the radian over 2. So that is how you change a degree to a radian. The same applies with the radian to degree now. You now multiply by 180 over a radian. For an example, let's say we are taking 2 radians. We want to change this into degrees. That means now you must multiply by 180 over radian. And then now the radian will cancel a radian. We left with 2 times 180, which is 360 degrees. Do you see grade 12? Exactly the same, because here we are having 360 degrees when you revolve up to that point. Okay, which is equal to the 2 radian. That is how you change degrees to radian and the radian to degrees. A tip is that if you are having a degree, ensure the degree is a denominator. If we are having a radian, ensure a radian is a denominator there. Those are the key ideas that we use in order to be able to remember that. And then here is your baseline grade 12, just to ensure you have all the pre-knowledge that is needed before we can start any activity. I am giving you 5 minutes to do this baseline assessment, and then we'll look at the solution after 5 minutes. Your 5 minutes starts now. Okay, grade 12, let's check how far did you go with this one. Remember our WhatsApp number, 079-454-9535. You are more than welcome to send your clarity-seeking questions to that particular number or any alternative solutions that you would like to share with the rest of the team, okay? And then now, before you can do any trig ratios and its reciprocal, remember, you need your SOHCAHTOA in your toolbox, and then you need to identify that sine goes with cosec, tangent goes with cot, a cos goes with sec there. Okay. So remember, in this quadrant, it's all your ratios, all these three ratios with the reciprocals in quadrant 1. Right, and then remember your reduction, you only use 180 minus, 180 plus, 360 minus, and then 360 plus. Now we are given a cos theta, we are identifying its ratios now. Like the first example is done for you. The sine of theta is opposite over hypotenuse. As you can see, the opposite over hypotenuse. That means its reciprocal will take the inverse of this one. It must be hypotenuse over the opposite side. It's hypotenuse over the opposite side. Now let's look at the cos now. Cos is adjacent over hypotenuse. That means it will be the adjacent side over the hypotenuse side. Now what is the reciprocal of cos? It's a sec of theta. And then sec of theta will be what, grade 12? The hypotenuse over the adjacent. You just swap around, okay? And then the tan of theta is opposite over adjacent from your SOHCAHTOA. And then what is the inverse of a tangent now? It's a cot. And if it's a cot of theta, if tangent is opposite over adjacent, the reciprocal will be adjacent over opposite. As easy as that, grade 12. And then now let's move to the reduction formulae. And then now with the reduction, we are looking at the sine. Sine is in quadrant 2. Remember, this is quadrant 1, quadrant 2, quadrant 3, anti-clockwise, quadrant 4. And then the sine of 180 minus theta, 180 minus theta is in quadrant 2. The sine is positive. Remember, the ratio that is inside that quadrant, it is taking control. It will be positive. But if tangent and cos can be in quadrant 2, they will be negative. It's only sine and cosec that are positive. So they are controlling quadrant 2. They are in charge of quadrant 2. So if we are in charge, you are positive. Any other ratios, if they can fall in your quadrant, they become negative, okay? And then now sine 180 minus is a sine quadrant, therefore sine will be positive. We have reduced now this in terms of x, okay? Look at the second one is sine 180 plus, that is quadrant 3. Is sine in that quadrant? No, that is a tangent and a cot quadrant. So if sine came into that quadrant, it will become negative now because it doesn't belong to that particular quadrant. Then it will be minus sine x. And then now let's look at the cos now. Cos of 180 minus quadrant number 2. Is cos positive there or negative? It is negative because it does not belong there. It's only sine and cosec that are positive. Then it will be negative cos x. I hope this is clear, grade 12. 180 plus, which quadrant is that? Quadrant 3. And then is cos positive and negative there? Tan is the only one that is positive and cot. Therefore, cos is negative. And then now 180 minus is quadrant number 2. We are here. Quadrant 2 is tangent positive or negative? It is negative because it does not own or belong to that quadrant. And then now 180 plus is quadrant number 3. We are in 3 now. And then is tan positive? Yes, tan is positive in that quadrant. Therefore, it will be positive tan x in quadrant 3. And then now we are moving on to 360 minus and 360 plus. We'll be talking quadrant 1 and 4. And then now in quadrant 1, all your ratios and its reciprocals, they are all positive in quadrant 1, all positive. That means when you talk 360 plus, they are all positive. We can even answer now all the 360 plus that it will be positive sine x, positive cos x, positive tan x, because so 360 plus is quadrant 1. Now let's look at 360 minus. 360 minus is quadrant 4. Is sine positive in there? No, it's only cos and sec, therefore sine is negative. And then in quadrant 4 again, is cos positive? Yes, cos is positive because we have a cos there, therefore it will be cos x. Tan in quadrant 4, no, tan is negative because it's only cos that is positive there. That is how you identify the reductions, grade 12s. And then with the identities, remember we have square identities and then we have the quotient identities. Sine squared plus cos squared equals to 1. 1 plus tan squared theta is a sec square theta. 1 plus cot squared theta is a cosec square theta. A tan theta is a sine theta over cos theta. And then if we're having a cot of theta there as another reciprocal, it will be the inverse of tangent, of which is cos theta over the sine of theta. Then grade 12, you have the correct solutions that were expected from you. I hope you got this one correct. And then let's move on to the lesson, straight to the lesson now. We are given that angle A is equal to 65 degrees. The value of angle A is equal to 65 degrees and the value of angle B is equal to 53 degrees. Now you need to determine the values of the following. Number 1, we are given the sine of B. So if you look at B, B is equal to 53. So here the method is of substitution. You will be substituting the given values there according in reference to the angles. Now if it shows A, you substitute 65. If it shows B, you substitute 53 degrees. And then let's start with 1.1. We are given sine B, therefore it will be the sine. We are substituting a B with what? 53 degrees. Ensure, grade 12, that you choose correctly. Do not mix the angles there. And then into your calculator now, because this one there's no indication of without using a calculator, therefore your answer will be 0.80. If not indicated, remember on your instruction sheet it will be indicated. Round off all your answers to 2 decimal places unless stated otherwise. Hence we are having 0.80 here. So the first mark will be for substituting, the second mark for the answer there. And then with 1.2, we are having a sec. That means we are having a reciprocal, because on your calculator we have only button for sine, for cos and a tangent. There's no button for sec. That means if you're having a sec, you must write it as its reciprocal. Do you remember sec goes with the cos? Okay. That means now you will be having equals to, we change first this one into 1 over a cos of A plus cos B. Then we substitute now A with, this will be cos 65 degrees plus the cos of B, which is 53 degrees. And then into your calculator, grade 12, to the answer to second decimal places, this will give us 2.97. That is the value of this identity or expression that was given to us. And then the first mark will be substituting into the correct reciprocal. This can even worth 3 marks, grade 12. An examiner can give a mark for changing the sec into its reciprocal, the second mark for the substitution, and the third mark for your final answer. This can worth up to 3 marks. Okay. And then now your activity, grade 12s, please go through this one on your own. We are still substituting. Please take no doubt you are having radians there. And then the first question, you convert that radian to degree, and then you determine with substitution the value of sec P plus cos Q. I am giving you 3 minutes, grade 12s, to do this activity. Your 3 minutes starts now. Okay, grade 12, let's check now how far did you go with this activity. Remember to send your questions to 079-454-9535. That is our WhatsApp number, 079-454-9535. And then now, in this case, you are given the angle P in radians, which is 2/7 radians, and then angle Q in degrees, which is 37 degrees. And then question 1.1, they say convert 2/7 radians to degrees. Do you still remember? If you are converting a radian, it must be over radian, okay? So now it will be 2/7 radian multiplied by 180 degrees over a radian. If you have a radian, radian must be a denominator. If you are having a degree must be the denominator, okay? And then now radian will cancel a radian, and then we are having 2/7 multiplied by 180 degrees, and then this is giving us 51,43 degrees. That means that is angle P. Our angle P now is equal to a 51,43 degrees. And then now 1.2, Okay, this is 1 mark, grade 12. You will be given only for an answer, because now some learners can see that if it is 2/7 radian, they must just multiply by 180. So they will do that in their calculator and give us the solution. Hence, there is no mark for the method. And then now 1.2, determine the value of sec P plus cos Q. Remember, the minute you have reciprocal, you must change that reciprocal back to its original ratio. And then now we are going to write this sec P in terms of 1 over cos P plus cos Q. And then now let's substitute now 1 over the cos of P is now, we have to do it in degrees so that we can work with degrees only now. And then now the value of P in degrees now is 51,43 degrees plus the cos of Q, which is 37 degrees. And then now you can put everything into your calculator to an answer rounded off to 2 decimal places. And then this is giving us 2,4. If it is 2 decimal places, it will be 40. So that is the simplified value of that identity. And then the first mark goes to correct reciprocal with substitution, and then your final answer. Other examiners can give you an independent mark for writing the reciprocal, and then this can worth up to 3 marks, grade 12. It depends on the examiner. And then now the next lesson, now we are looking at where you are using a diagram to solve your problems. We call this using sketches or using a diagram or by the aid of a diagram. And then now we are given that tan alpha is equal to 2/3, and alpha is an element, or it lies between 180 degrees and 360 degrees. And then they say determine with the aid of a diagram. That is why we are saying this is the type of using a diagram, using a sketch, and so forth. So now you must see this keyword that is directing you the method to use to solve this one. Okay, and then now without using a calculator. So in this lesson, you are not allowed to use a calculator. Okay, and then you have to determine the value of 4 cot alpha plus the sine squared alpha. So grade 12, with this type of a question, the mistake that you do is you want to start by attempting answering that question. You cannot win by doing that. So if you see the type of using a sketches type of question, the first thing or your starting point is from the ratio that is given to you, not from the question that is asked from you. So you start from this ratio. That is the first number, the first step. The second step, identify which, from your Pythagoras, between x, y, r, which one is missing. Step number 3, identify the diagram in which quadrant you will be working. And then you go Pythagoras and find the unknown. It's only then that you can answer this. So number 1, you look at the ratio given. Number 2, you identify the quadrant. Number 3, you calculate the unknown using Pythagoras theorem. After going this route, it's only then that you can now answer your question. You cannot answer the question before you go all the above 3 steps. Okay, now let's start. Now we are having a ratio given to us, which is tan alpha equal to 2/3. And then from tan alpha, identify what is given. Remember your SOHCAHTOA? A tangent is opposite over adjacent. In a Cartesian, opposite is y, adjacent is x. That means now we are given what here? Y over x. It simply means y will be 2 and the x will be 3 there. So as you look at that into Pythagoras theorem, r squared equal to x squared plus y squared, you can see now you have a shortage of r there because x is there and the y is there. Okay, but you cannot go to Pythagoras before you go to the quadrant. Can you see that? Step number 2, you must identify the quadrant. So if you look at your ratio now, remember the cast diagram. The tangent is positive in quadrant 1 because all ratios are positive there, and then it's also positive in quadrant 3. And then the rotation is 0 there, 90 degrees, 180 degrees, 270, and 360 there. Okay, so now we have identified, all right, tangent will be positive in quadrant 1 and quadrant 3 according to the cast diagram. Since it is giving us 2, we need 1 where we can sketch now in a quadrant. So now since we are having 2 here, that is why we are having that restriction, which will cut off 1 and you will remain with only 1, which is your final quadrant. So this restriction is saying to us alpha must be an element of 180 to 360. That means from this line to that one. So from 180 to 360. So where do we have a line and a cross is in quadrant 3. Can you see in quadrant 1 you have only a cross? So that means the one that qualifies is where you have both. You can't take quadrant 4 because there's no cross in quadrant 4. Okay, and then now we can now put in the value of y is 2, the value of x is 3, and then we are looking for the value of r. And then great job. If you look at this diagram, it is assisting us to finalize whether the value is positive or negative. If you look at this diagram now, it is showing us that the x value is supposed to be negative and the y value must be negative because the x values this side, they are negative, and the y values there, they are negative. So without this diagram, you will never know that your x was supposed to be negative. And then one learner can ask, why is it now given as being positive there? It's because it was a negative 2 divided by negative 3, of which a negative divided by negative is a positive. That is why it is given as being positive here. But initially, this is negative 3 and negative 2. By the aid of the diagram, it is assisting us to get the real signs of our values. And then we have a diagram in quadrant now. We can now go Pythagoras theorem. Pythagoras says that r squared is equal to x squared plus y squared. And then if this side loses an exponent, this will gain plus minus. But because it's a hypotenuse side, r is always positive. There's no way that you can have a negative r. So we substitute the value of x, which is minus 3, the value of y minus 2 squared. And then into your calculator, grade 12, this will give us the square root of 13 because it will be 9 plus 4, which is 13. And then this will be square root of 13. That is the value of r. Remember now, when you are clustering your information, you have x, which is minus 3, and the y that is minus 2. So now we will be working with this only if our angle is alpha now. It is only then that we can answer the question that was asked from us. So our question is for cot alpha plus the sine squared alpha. We need to simplify that without using a calculator. And then this is equals to 4. Remember now, a cot is a reciprocal of a tangent. Tangent is y over x, therefore cot will be x over y. Do you still remember that? Plus a sine. Sine is opposite over hypotenuse. O is y and h is r. That means is y over r. And remember, this is squared now. So after identifying the variables or the values that we are going to take now, we can now substitute x is what? Minus 3. Y is minus 2. Plus y is minus 2. R is square root of 13. And this is squared. And then now grade 12, so we are having 4 Okay, it's 4 times minus 3, that is 4, 8, 12 over minus 2 plus the negative 2 squared is positive 4. The square root of 13 squared, that is 13. And then you apply your LCM method to your answer for this one. You will end up with the final answer of 82 over 13 there. So now we have 5 marks for this. The first mark will be for the correct diagram in the correct quadrant, indicating your values of y and x. The second mark will be for the substitution into Pythagoras theorem, correctly substituted. The third mark will be for the value of r, and the fourth mark will be for substituting correctly into the given expression. The final mark will be for your answer there. And then that is how we allocate that 5 marks. Grade 12. Remember, the method is ratio, quadrant, Pythagoras, and then we can now start answering your question. You need your soccer tower, you need your cast diagram, you need your Pythagoras to work with this type of questions. And then there is your activity grade 12. Lucky enough, the diagram is already given to you. Remember, you need a ratio, you need a diagram. If the diagram is given, that means you can go to Pythagoras straight. Because why? The diagram is given. No diagram, no Pythagoras, okay? And then in the diagram here, we are given OA is equal to 3. Then, and then we are given A, which is minus square root 5, and X, and K, remember this is representing X and Y. And then is a point on a Cartesian plane. The angle of inclination of OA with respect to positive axis is theta there. And then now determine with the use of, without the use of calculator, the numerical value of K, of which is that one, and also 2.2, the square root of 5, cot theta plus 1. And then grade 12, I'm giving you 3 minutes to do this activity. And then after 3 minutes, we will be reflecting back. Your 3 minutes starts now. Okay, grade 12, let's see now how far did you go with this one, or how many marks can you get out of this 5 marks. Okay, now we are determining without using a calculator the numerical value of k. So if you look at k here, that is the coordinate y on the given point there, point A. So now we have 3, which is r, and then we have x, which is minus square root 5. We have a diagram, therefore we can go straight Pythagoras. R squared is equal to x squared plus y squared. Then we are going to substitute our r is 3 squared, and the x is minus square root 5 squared, and the y is k squared. And then 3 squared is 9, minus square root 5 squared is 5, plus k squared. And then we transpose 5 to the left hand side. It will be 9 minus 5, which is 4. Therefore k will be plus minus the square root of 4, and then which is plus minus 2. But now if you look at k is on the positive y values. Can you see that? It's a y value of which is positive, because the y values are positive. That means we can conclude that the value of k must be only positive 2. Okay, and then now move on. Okay, let's allocate marks. 1 mark will be for substitution, and the 1 mark for the correctly selected value of k, of which is positive k, grade 12. And then now with number 2.2, square root of 5 cot theta plus 1 is equal to square root of 5, and the cot of theta, remember SOHCAHTOA, a tangent is y over x. That means if cot is a reciprocal of a tangent, it will take x over y. And then plus 1. Let's substitute now. Square root of 5. What is x? X is minus square root 5 over y is 2, because it's k. And then plus 1. And then we have the square root of 5 multiplied by negative square root of 5. That is negative 5 over 2 plus 1, and then negative 5 over 2 plus 1, that is negative 3 over 2, without using a calculator. You use your LCM method. And then this is 3 marks. The first mark will be for substitution. A second mark will be for simplifying the square root signs. The third mark will be for your answer, which is correctly minus 3 over 2. Okay, or you can write as minus 1,5, because you know that 2 goes once into 3, and then you'll be left with 0.5 then. So that is activity number 2, solution grade 12. And then this is worth 3 marks. At least I know you got 100% on that one. It's straight and forward. And then the next lesson, now we are still on trigonometry. We look at the equations now, where you are solving trigonometric equations. So we are solving for x. If we are given the cosec of x being equal to minus 3,054, and x must be an element of 0 to 360. That means the value of x can be any value from 0 to 360. That means it can be in all quadrants. Okay, it is acceptable. Now here we have a cosec. We need to change this to its reciprocal. Do you still remember that cosec goes with what? With a sign in second quadrant, right? Then it will be 1 over sine x equal to minus 3,054. We are only using that part, correct? And then now from here, we want to solve sine equal to, we are going to cross multiply. and then 1 times 1 will be 1 over minus 3,054, and the sign will go to this side, and then it will be sine x there. We have cross multiplied. Okay, and then the next step now, this is the same as the sine x equal to minus 1 over 3,054. So the method is from here now, because we want to solve for x, you can't solve immediately. We must look for the reference angle, because we will be solving in the quadrant where sine is negative. So in which quadrant you will be solving, grade 12, where sine is negative? Do you still remember your cast diagram? Sine is negative in quadrant 3 and 4. And then what is the reduction in quadrant 3? 180 plus. In quadrant 4, 360 minus. So we will be using this information now in order to solve for this x value. So now we start by looking at the reference angle. We are not yet solving. So the reference angle, you'll be taking this sign to this side. It will be sine arc sine of, we don't look at the negative because the negative is showing us quadrants. Okay, so we'll take 1 over 3,054 as being positive. So this is giving us a reference angle of 19,11 to the second decimal. That is our reference angle. Then after finding the reference angle, now you can now solve in the quadrant. We have said that we will be solving in the third quadrant. So in the third quadrant is x value is equal to the reduction in that quadrant, 180 degrees plus. We are referring to the reduction there. And then now what must be added is your reference angle, which is 19,11 degrees. So if you add the two, grade 12, we end up with 119 is 180 plus 19, that is 199,11 degrees. Can you see the value is still in quadrant 3? And then now we can now also solve in quadrant 4. In the fourth quadrant, we are having x is equal to the reduction in that quadrant is 360 degrees minus, reduction in that quadrant 360 minus what? The reference angle 19,11 degrees. And then 360 minus 19,11 is 340,89 degrees. So that is the value of x in quadrant 4. And then the first mark now goes to changing its reciprocal. Number 2 for end up with the sine x equal to minus 1 over 3,054. The third mark goes to the reference angle 19,11. The fourth mark for the first value in third quadrant, the last mark for the value in the fourth quadrant. Therefore, this is the allocation of your 5 marks grade 12s. Do you see the method right? In this case, is because we were having the reciprocal. That is why we were starting by changing this. And then now you must have a reference angle. And then the reference angle, you check the ratio, is it positive or negative, in which quadrant is it positive. And then thirdly, now you are going to solve in those quadrants. Do you get it, grade 12? All right. You identify the quadrants you'll be working in. You identify the reference angle. You solve in the quadrants identified, whether being positive or negative ratio. And then let's see now how far do you understand on this one. This is your activity, same application as the previous one. Determine the value or values of x if 3 times x is equal to minus 0,531, and then x must be an element of 0 to 360 degrees. I am giving you 3 minutes, grade 12, to go through this one, and then we will be reflecting back your solutions after 3 minutes. Okay, grade 12, remember our WhatsApp number 079-454-9535. You can send your clarity seeking questions to that particular number. Right, with this one, we are a little bit challenged because now our ratio is having a coefficient. We have a number which is 3 there. So we need to remove that 3 first so that you can have your ratio equal to something before you go to your reference angle. So we are going to divide both sides by 3. Then we'll be left with tan x equal to minus 177, and then we are solving this between 0 and 360, right? And then the next step, the minute you have a ratio now and then it is not a reciprocal, so you can go straight to your reference angle, of which it will be the arctan. Remember, the negative is indicating quadrants, so we will check the quadrant after looking at the reference angle 0177, and then our reference angle in this case, it will be 10,04 degrees. That is your reference, it is not yet your solution. So we are going to look at tangent where tan is negative now. In which quadrant is tan negative? Look at your cast diagram again. Tangent is negative in quadrant 2 and 4 because they are all positive there and tan is positive there. So we will be working in quadrant 2 and 4. So in quadrant 2 we have 180 minus because it's before. And then in quadrant 4 we have 360 minus because it's before 360. So we are relying on these reductions now to solve for x there. So now we will start with quadrant 2, second quadrant. Our angle x is equal to reduction in quadrant 2, 180 minus which angle? Reference 10,04. And then 180 minus 10, that is 160. Okay, 180 minus 10,04, that is 169,06 there. Okay, that is the degrees for that. And then now we go to the fourth quadrant, and then in the fourth quadrant we are looking at the reduction there. So the reduction in quadrant 4, so we have our angle x, it will be 360 degrees minus. We are taking that reduction, and then minus what? Our reference angle 10,04 degrees. And then 360 minus 10,04 degrees, that means it will be 359,06 degrees for that. So that is the value of that angle. And then grade 12, you must also check the values that you get there are within the interval that is given to you. They must lie between 0 and 360 to be satisfying values of x there. So our values are both correct. And then 1 mark will be for the correct ratio there, simplified by dividing by 3. Second mark will be for that reference angle. The third mark will be the value of x in quadrant 2. The fourth mark, value of x in quadrant 4. Then this is worth 4 marks then. Okay, the next lesson is on reduction. So when we are using the reduction formula now, remember we need the cast diagram. We need the cast diagram, grade 12 on this one. No matter what, you must have your cast diagram. Reduction lies mostly on that one. And then remember, reduction, we only use 180 degrees and 360 degrees. And remember, this can also be in radians, and this one can be in 2 radians. Okay, this is 180 minus 180 plus 360 minus 360 plus. And then now, happy, we have our diagram. that we will be referring to. Right, let's start now. In this case, you'll be checking the ratio in the quadrant in terms of reduction, and you are reducing all the angles to be in terms of B now. And then in this case, we have a reciprocal there, so we must deal with that reciprocal also. Right. So we have 2 here, and then now this is 2, and then the sign of radian plus B, radian plus, that is quadrant 3. Is sign positive there? No, sign is negative. Then it will be minus sign B there. Multiply, please avoid using a dot, because sometimes if your ratio brings a negative, you end up subtracting instead of multiplying. Change the dot to multiplication sign to remind you, okay? And then we have 2 radians minus B, that is quadrant 4. Cos is positive in that quadrant. That means it will remain cos B. Remember, these values here are only showing you the quadrant, grade 12, okay? And then multiply by 180 minus is quadrant 2. It's only sign that is positive. That means tangent is negative in that quadrant. 180 minus quadrant 2 is only sign positive, therefore this cos will be negative. Then it's minus cos B there. Multiply. And then if you look at this now, it will be 2 over. Remember, sec goes together with the cos, right? That means if it is cos, sec is also in that quadrant. So 180 plus is quadrant 3, then sec in that quadrant, it will be negative because sec is only positive in quadrant 4. Then this will be 2 over sec, negative sec B, because it's in quadrant 3, negative sec B. Right, let's simplify further. A positive 2 times negative sine B, it will be negative 2 sine B. Multiply by cos B, multiply by negative tan B. A tangent can be written as its identity, sine over cos, sine B over cos B. Positive times a negative is a negative, or you can say this negative multiplied by that negative, you'll still have a positive cos B. And then now let's simplify this one, grade 12. We are having, remember, a negative and negative, we have already multiplied that one, it is no more there. We are left with only 2 divided by sec B. So this is the same as 2 divided by 1 over cos B. It's reciprocal. So if we change this to multiplication, it will be 2 times, remember, it will be now cos B over 1, which is cos B. So can you see that we will end up with 2 cos B for the whole expression there. So this will be multiplied by 2 cos B. Okay, and then continue. This cos now, because it's on the denominator, that one is numerator, they can cancel because we are multiplying. And then we'll be left with minus 2B, minus 2 sine B, multiply by minus sine B, plus cos B times 2 cos B, it will be plus 2 cos squared B. And then now this side, we are having a negative times a negative, it will be a positive. And then 2 sine B times 2 times sine B, it will be 2 sine squared B, plus 2 cos squared B. And then we have a common factor 2 there, we take out a 2, we'll be left with sine squared B plus cos squared B. And then do you still remember the identity? Sine squared plus cos squared is equals to 1. Therefore 2 times 1 is a 2. That means if we simplify this big expression, the answer will be 2. applying all your trigonometric identities and the reductions there. And then the important part, grade 12. This is the most carrying marks in trigonometry, because now by reducing your angles, you will be getting a lot of marks there. Let's see now. So the cast diagram plays a major role here. So 1 mark will be for minus 2 sine beta. If you end up being at minus 2 sine beta, sine B, that will be your first mark. The second mark for cos B, reduction of cos. The third mark for minus tan B. The fourth mark for cos B. Can you see? Reduction. Out of the 9 marks there, you are having 4 marks already for that. And then the fifth mark will be for 2 cos beta there, for changing that sec into its reciprocal. That will be your mark number 5. And the sixth mark for writing a tangent as its identity sine over cos. That will be the 6th mark. Out of the 9 marks, we are now left with 3 marks. That will be for simplification, for end up being with 2 sine squared plus 2 cos squared, for taking out a common factor, and then for writing that as an identity, or end up being with an answer 2 there. That is your 9 marks. Can you see? It's a lot, grade 12, but most of the marks are on reduction part here. You must ensure that you double check the quadrant and the sign of the ratio, is it correctly reduced, so that you can collect more marks on that. And then that is your marks, grade 12s. And then now you have your activity there, 3 marks to do that activity, and then we will reflect back after that. Your 3 minutes starts now. Okay, grade 12, let's see out of 8 marks, how many marks did you collect on this particular problem? Remember, you need your cast diagram that will assist you a lot in terms of reduction questions. Okay, now we are having 360 minus alpha. Which quadrant is that one? That is quadrant 4. Is sign positive? No, it's only cos that is positive. That means sign is negative. Then you reduce this to alpha because now you have already used the quadrant there. And then dot is multiplication. And then 180 minus, that is quadrant 2. Is tan positive there? No, it's only sign. Then that is negative tan alpha in quadrant 2. Multiply by cosec, remember, goes with the sign. It's also in quadrant 2. Now in this one, it is 2 radian minus alpha. 2 radian minus alpha is quadrant 4. Is cosec positive then? No, it's only cos and sec. That means cosec is negative then. Look at this. The minute you have checked the quadrant, we have now reduced everything into alpha. Okay. And then now 360 plus alpha, that is quadrant 1. And then all ratios are positive in quadrant 1. Therefore, cos will be cos alpha positive. Multiply by 180 minus quadrant 2 cosec. Yes, cosec is positive in there. That means it will remain positive cosec alpha. Multiply by alpha minus the radian minus alpha, sorry. Radian minus alpha. Radian minus alpha is quadrant 2. And then if you look at quadrant 2 now, tangent is negative in there. Now, grade 12, with this one, you must be very careful. The tangent is negative and the tangent is squared. Do not write positive tangent because tangent in quadrant 2 is negative. You need to show us first that this tangent is negative tan alpha. And then you can put your square out for now. You can't give us the simplified tan squared alpha, assuming that we automatically know that you were having a negative, you decided to square the negative before you give the final answer. Show us first that the tangent is taking negative. You will square the answer after. Okay. And then now we have minus sine alpha on top and then multiply. We can automatically cancel that because we are multiplying throughout. The cosec alpha will cancel cosec alpha. So we are left with minus sine alpha, multiply by minus. A tangent will be sine alpha. We are taking its identity over cos alpha. Okay, and then remember now this negative remains here, which is negative 1 of the cosec. Denominator, we have cos alpha, multiply by, this is positive 1, we have divided that, and then multiply by negative tan squared, it will be positive tan squared alpha. Okay, or we can write this in terms of sine over cos automatically. It will be negative, it will be positive sine squared alpha over the cos squared alpha, taking the identity now. Continue. We have 3 negatives on top. Negative times negative is a positive, times a negative is a negative. So our answer for the numerator top part will be negative, okay? So this will be negative sine times sine, which is sine squared alpha over cos alpha. That is for the numerator part. For the denominator part, it will be a cos is on top, it will cancel 1 cos there. So this will be divided by sine squared alpha over the cos alpha. This answer is for the top part, this one is for the below part. Because the cos is on top, this one, it will take 1 cos from that cos squared, okay? And then now continuing, it will be a negative divided by positive, it's fine. We will still have minus sine squared alpha over the cos of alpha. We change this to multiplication, it will take the reciprocal cos alpha over the sine squared alpha here. And the sine squared goes once, cos alpha goes once, then the answer will just be -1. And then let's look at the mark allocation now. For this particular, it will be minus sine alpha, minus tan alpha, minus cosec alpha, cos alpha, mark number 4, cosec alpha, number 5, and then the negative tan alpha squared. Then at this step, only grade 12, we are having 6 marks out of 8. So the remaining 2 marks will be for simplifying, for writing sine squared and cos squared. Some for the tangent, if you went that route, then you'll get a mark for that one. And then now for getting the final answer, -1 is for simplification and the final answer. The lot of marks are on reduction, so please ensure that you master your reduction there. And then now lesson 5 is on identities, of which is the last lesson for us. With the identities, remember, you look at the bracket of square identities, quotient identities, and the reciprocal identities. That is what we are using. So you'll be given left hand side equal to the right hand side, and that means the answer is given to you. This is your answer. So you need to prove the left hand side that you'll get the answer that is tan theta now. Okay, let's start doing so, grade 12. We are having our identity there. We are going to take the left hand side only. And then with the left hand side there, we are going to have a cos theta plus the sine squared theta multiply by a sec. Do you still remember a sec is 1 over cos? Because it's a reciprocal of cos. And then divide by the cosec, it's 1 over sine. It's a reciprocal. And then from here now, we end up with a cos theta plus sine squared theta times 1 is a sine squared theta over 1 times cos theta, it's a cos theta there. And then divide by, let me write a division this side for 1 over sine to avoid many divisions that will confuse us. So you can see that numerator part, you are adding fractions. So you need to look at the LCM of these two. That will be the cos theta. And then now 1 into cos theta times cos theta, it will be cos squared theta plus cos theta into cos theta 1 times sine squared, it will be sine squared theta there. LCM application method. And then now from here now 1 over sine theta, we can change the division to multiplication, it will be sine theta there. So now the cos squared theta plus sine squared theta is the same as sine squared theta plus cos squared theta is the same thing. So which will give us 1 over cos theta multiply by sine theta. And then 1 times sine theta is a sine theta over cos times 1 is a cos theta. So sine over cos is a tangent identity. Okay. So therefore, your left-hand side is equal to the right-hand side. And then let's allocate marks now, grade 12. The first mark will be for writing a sec in terms of 1 over cos. The second mark for writing a cosec in terms of 1 over sine. And the third mark is for simplifying and end up with this LCM simplification. And the fourth mark is for knowing that cos squared plus sine squared is 1. And the last mark will be sine theta over cos theta. We are not going to allocate a mark for tan theta because the answer was given to you. So the marks will be up to the sine over cos. Remember to include this conclusion. Some examiners, they give marks for that, okay? And then this is your activity, grade 12. First 3 minutes on that one. That is the last activity for the day. Your 3 minutes starts now. Okay, grade 12, this is 4 marks. Let's see now. Remember, you work with only one side. You cannot take both. Even though in some cases both sides can work for you, I'll show you with this one now. So now if you decide to take the left hand side, that means you must get the answer like that eventually. This will be your answer, right? And then we have a cosec there. That means you'll write this in terms of its reciprocal. That is 1 over sine x. I hope you are now familiar with these reciprocals now. And then this is sine x if there is no denominators over 1. So now here is a subtraction of fractions. That means we consider the LCM method. That will be our LCM is sine x. And then now sine x into sine x once. 1 times 1 is 1. Minus 1 into sine x times 2, that is sine squared x. Okay, and then 1 minus sine squared is a cos squared x over the sine x. Okay, remember, if you need a cot x, we are looking for cos x over sine x, correct? So if you look at the numerator, there we are having 2 cos's because it's cos squared. So it's a cos multiplied by cos over sine x. So this one will create a cot. And then multiply by the remaining cos x. Therefore, your left hand side is equal to the right hand side, and the first mark there will be allocated to 1 over sine x, and the second mark for application of LCM correctly so, and then the third mark for writing the identity 1 minus sine squared as cos squared x, and then now for having cos x over sine x there, and then separation of that to create a cos over sine. That will be the 4th mark. And then one learner maybe see an answer on the right hand side, decided to take this side instead of the left hand side. That means this particular learner must get the left hand side answer now. And then now for the cot, the learner wrote that as a cos x over the sine x identity multiplied by the cos x. And then now the cos times cos will be cos squared x over the sine of x. And then the cos squared x back to its identity 1 minus sine squared x. And then this will have, okay, over sine x here. Sorry for that. We have an LCM sine x. Continuing, we are going to separate this to its original LCM 1 over sine x, or denominator, minus sine squared over sine x. And then 1 over sine, remember, is a reciprocal of a cosec. Then we can write this as cosec x minus sine into sine squared goes once, we are left with only sine x. Can you see that is the answer that is given there? Therefore, your left hand side is equal to the right hand side also, great chaps. And then this is also 4 marks. It will be allocated the same way as we have allocated. And then that is your homework, great chaps. And then you may go through the homework at your own time. And then now the summary of the lesson. Now with trig that you have treated today, you must know your trig ratios and its reciprocal. You must know how to apply reduction formula using the cast diagram. You must know your trig identities, the square identity, the reciprocal identities, and the quotient identities. You must know how to solve your trig ratios, where you identify the reference angle and then you solve in quadrants. This is the basic of the today's lesson, grade 12. And then the review of the next lesson just in time. Our next lesson will be on the 23rd of April 2025 from 2:30 to 4 o'clock, and then we will be looking still on trigonometry, the 2-dimensional and 3-dimensional problems, and our trigonometric functions. grade 12. See you then. Thank you very much for today.